Welcome to Learn Yourself. Today we are going to discuss about refractive index, and this is from the CBSE Standard 10 syllabus. In my previous videos we have discussed about refraction through glass slab. If you have any doubt regarding refraction phenomena, then please refer my video and then come back to this topic. So this topic is the refractive index, a ray of light that travels obliquely from one transparent medium to another will change its direction in the second medium. Now we have seen that if this is an interface of the surface, that means from here another medium is starting and here the medium is there. So this we are referring as medium 1 and this we are referring as medium 2. Now suppose this is a medium air and this is a medium glass, that I am taking example of refraction through glass slab. Here we have seen that if this is a normal is a perpendicular to any surface. So when a ray is coming obliquely from one medium, so this is air and ray is coming obliquely. Obliquely means a slanting. So when a slanting or oblique ray is falling on the surface of one of the medium and it is passing through this and it is going to travel in the second medium. So what will happen? We have to see the density difference between these two medium. If this medium is rare and this medium is dense, now it is always comparable that whenever you have two mediums with you, one medium will be denser and one medium will be rarer. For example, we are taking air and glass. Into that, air is a rarer medium and glass is a denser medium. Whose density is more will become denser medium. Now when we are taking air and water, so water will become denser and air will become rarer. But water is denser because other medium is air. If we are taking water and oil, then water will become rarer and oil will become denser. So it is always relative that which two medium you are comparing with each other and which two medium the light is passing. So here when it is coming from rarer medium to denser medium, it will bend towards the normal like this because its speed will decrease. Here the speed is more and here the speed will decrease because it is denser medium. And again when it is going out from the denser medium to rarer medium, here this is a normal. If this is a normal here, then it will move away from the normal like this because again its speed will increase. It is when it is going from denser medium to rarer medium. So this is a refraction. When light will bend because it is traveling in another media or it is just changing its medium, so it will bend. This refraction is happening because light is changing its medium, either from rarer to denser or from denser to rarer. Now it will move towards the normal or it will go away from the normal. That is depending upon is it coming from rarer to denser or from denser to rarer. But the phenomena of bending of the light is known as refraction. So both the ways it is refraction. So here a ray of light that travels obliquely from one transparent medium, any transparent medium, into another. So either it is from this to this or this to this. Into another will change its direction in the second medium. So that is refraction and the extent of change in direction that take place. Now we know that it will get refracted, it will change its direction. That from here to here or from here to here it is changing its direction. But how much it is changing direction, that measure will give us refractive index. So whenever we are checking that how much it has bent or how much it is going to bend, so that we can measure it through refractive index. The extent of change means how much change will happen in the direction that take place in a given pair of media. It is always a pair of media. There will be always two media. One will be rarer medium and one will be denser medium. may be expressed in terms of the refractive index. So what is a refractive index? That how much light has bent, that extent, that measure or that physical quantity is our refractive index. Now light is traveling fastest into the vacuum and its speed in the vacuum is 3 into 10 raised to 8 meter per second. Now into the air the speed is marginally less, so it is almost equal to vacuum only. So in air also we are taking light speed is equal to 3 into 10 raised to 8 meter per second. Actually if we are going into the physical quantity then it is little less compared to this, but it is almost equal to this. So we are taking the speed of light in air also this. Now this speed is very less in water and into the glass. Now let us derive the formula of refractive index. So here we are going to derive formula for the refractive index. So here we are taking ratio of speed of light in medium 1 divided by speed of light in medium 2. So that ratio will be our refractive index, and that we are representing with n. So here two medium are there. This is air medium and this is glass medium. So from air the ray is obliquely falling on the surface of the glass and it is passing through the glass slab. These two mediums are there, and here this is I. I means angle of incidence, and here R means angle of refraction. How much ever it is refracting, that we can see it from the angle of refraction, and here angle of incidence. This is incident ray and this is refracted ray. Now when we are taking a ratio of these two, then speed of light we are considering in medium 1 is V1, whereas speed of light in medium 2 we are considering as V2. So first we are taking a ratio of V1 by V2. So in the numerator we are going to write the speed of light in medium 1, and that is going to be V1, divided by we are taking speed of light in medium 2 equals to V2. Now this is our refractive index. So here what we are doing is we are checking the refractive index of medium 2 with respect to medium 1, because ray is coming obliquely and that is falling over here on this surface, and then it is going to bend. So actually we are going to find here the refractive index of glass medium, that when ray is coming through the air, how much it is bending. So actually this ratio is for the finding refractive index for the second medium, and that is glass medium. Here it is not bending because that medium is air, and even if it is bending, we are checking that with respect to this ray, that this ray is our reference ray, and compared to this ray, how much this ray has got refracted or it got bent. So that we are finding here. So speed of light in medium 1, that we are taking as a reference, and we are finding it the refractive index for the medium 2. So refractive index 2,1 means we are finding for the second medium with respect to medium 1. So that is our ratio for the medium 1 divided by medium 2. Now in second case, when we are finding out the refractive index for the medium 1, that if we are taking this ray OB as our reference ray, then that will come into the numerator, that speed of light in medium 2 equals to V2 divided by speed of light in medium 1 equals to V1. Now here the opposite thing we are doing, that with respect to this ray, we are finding out the bendness of the second ray, that with respect to this OB ray as a reference ray, we are checking that how much this OA ray has got bent. So that is V2 divided by V1. So refractive index here, that we are taking a reference medium 2 and we are finding for the medium 1 that how much it is bent. So this is a refractive index 1, 2, that is speed of light in medium 2, speed of divided by speed of light in medium 1, that is V2 divided by V1. So these are the general formulas when we are checking and when we are making one of the ray a reference ray, because otherwise we will not be able to find out that how much that ray has got bent. If we are checking that this line is slightly slanting, then how you will check that how much it has slant? With reference to one of the line which is straight. That we need always a reference to check that how much this line is slanting. So like that, one of the ray, when we are comparing two medium, one of the ray we have to make a reference to check the other ray has got how much bending or how much it is bending when it is passing through that. So when you are finding for this, we are making this as a reference ray, or when you are finding for AO, you are making OB as reference ray. And that is how it will work for the refractive index. Now let us consider our one of the medium is air, and that is fixed because we are taking air as a medium where the light speed is maximum and there it is not bending. It travels straight through the air. So one of the medium when we are taking air, and with respect to air when we are checking a different mediums like glass, water, oil, and when we are taking this two comparison, that air with respect to all the other medium, then that refractive index is known as absolute refractive index. When we are checking any other medium with respect to only air, that refractive index is known as absolute refractive index. So in our syllabus, whatever refractive index we are studying are absolute refractive index, because we are always going to calculate the refractive index of any medium with respect to air. So all the absolute refractive index in general will known as refractive index. Now let us write the formula for the absolute refractive index or refractive index in which one of the medium will be air. So this is our refractive index or absolute refractive index in which we are taking speed of light in air divided by speed of light in any medium. So here we are taking any medium like oil, water, glass, any medium. So here speed of light in air is c, whereas speed of light in any medium we are considering as a v. So we know that speed of light in the air is 3 into 10 raised to 8 meter per second and divided by v, and here refractive index will be there. So based on this formula, we are going to solve many problems in which one of the thing will be given to you. We know this. So we can find out either the refractive index of the medium or we will find out the speed of light in that particular medium. So hope this video has solved your doubt. In coming videos we are going to solve many more important concepts. So don't forget to subscribe, learn yourself. I'll see you in next video. Till then, keep learning, keep sharing.